Sight before sound. You see the rustle of leaves before you hear the wind blowing through bamboo. Like a canvas is to a painter, I am fascinated by computers because they offer an infinite canvas to defy physical limits and make the impossible. No permissions required. They expand the range of play for seeing and searching.
This is Ernie, and in this series of video essays, which can be seen independently or together, I want to argue that access to art can be elevated by making it available as a form of data. Next, I will go on to showcase ways as well as limitations of seeing enabled by machines on such forms of data. After that, you will get the opportunity to build your own neural search engine on top of your collections via point and click. Finally, I will conclude how the symbiosis of open GLAM and open source can not only help us to move from proof of concept to production, but also branch the way that we work for a more sustainable future. What I'm about to present, I'm telling my own views, and I'll be more than happy to hear your take or questions on these matters too. My intention here really is to seek to raise lots of questions on the one hand, and then to collaborate on the other. With that, let's get started.
Let's begin by better understanding what is artificial intelligence. While large language models like GPT and deep learning are very much the talk of town at the moment, they represent a highly narrow and specific subset of artificial intelligence. To me, the artificial here simply refers to silicon or non-meat substrate, and intelligence is learning and reasoning like humans do. Conceived this way, AI is many magnitudes bigger than even what big tech or the current hype cycle would lead us to believe. It should really command the attention of all artists, philosophers, and everyone really, the same way that the steam engine, knowingly or unknowingly, completely took hold of everyone's lives at the 18th and 19th centuries.
To get at how we can see and search with machines, it's helpful to start by asking what is AI's favorite art movement. According to ChatGPT, it will be pointillism, because it's all about data points. Rather than pigments on a palette, pointillist pressed dots of cyan, magenta, yellow, and key before the world had printers. Similarly, an artwork or an image is represented to the computer as a pixel of red, green, and blue lights. Once you have pixel representations of these artworks, the problem is that typically they are not really accessible or searchable due to the limitations of traditional keyword-based approaches, which requires a lot of manual tagging. Both time and manpower are limited. So the starting point for our inquiry is to examine ways of seeing and searching that goes beyond existing metadata to augment existing efforts at National Gallery Singapore. This will help to make art accessible to the public. Opening up the collection this way creates new modes of engagement, new entry points for new audiences to create their own meanings with artworks, as well as greater relevance to contemporary conversations.
Before search, the machine needs to be able to see and sense make on collections. We also want to be able to capture and model the relationships between different modalities of text, image, video, sound, and maybe even 3D meshes. Which is why we need to talk about embeddings, the machine's secret recipe for learning meaningful representations that capture the underlying relationships or structures between different data points. Take something like an image. It can have millions or even billions of dimensions if each pixel is considered a separate dimension. Embeddings can be used to represent images as fixed-length vectors, making them easier to work with in machine learning models. Once the embeddings are learned, algorithms such as TSNE, T-distributed stochastic neighbor embedding, can be used to visualize the relationships between the images in a low-dimensional space.
Here you see images projected via an unsupervised learning method, the TSNE algorithm, into a simplified low-dimensional space, clustering light images together. The machine learns to cluster light images together by stepping through iterations. Every run is a new experience. While the human eye is limited to seeing one visual perspective at any one point in time, machines can ingest as many images as memory allows. While such image data critically lacks the hyperdimensionality of reality, theoretically they can be expanded to include as many attributes as necessary. Such images are dispersed in space in relation to one another, thereby making the job of a search query simply finding the nearest points to what the user enters. This is what seeing with machines enables. Text can also be an embedding. This is how this string, a cute cat, relates to this image. Combine both in the same space, and AI becomes multi-modal, like we are. A cute cat is closer to this image, while the dog is some distance away. All the world is data that can be represented in some form, save for the fabric of subjective biological realities maybe. Give me processing powerful enough and epochs upon epochs to evolve, and I shall compute the world.
So an image is a collection of pixels, with text meanings as ascribed through research and conversation. A video is a series of images, and audio is text in another form. The rise of multimodal AI therefore enables us to see, process, transform and search with machines in ways that have been hitherto impossible. The machine dreams and hallucinates, a silicon imagination seducing humans with the appearances of plausibility despite its inherent ability to reason or comprehend. That is such an hourly great autocomplete machine should perhaps lead us to question our ways of working, our relationship to work. Are most work correspondences really generating one token after another? If so, why do we need a human rather than a machine? What makes a human human when machines can perform seemingly more intelligent jobs than what the intellectually disabled amongst us is capable of? Ways of seeing of machines as presented are bigger than us, for they can hold more images. They are smaller than us, as they simplify dimensions through mathematical transformations. They are stochastic machines, and whether supervised or unsupervised, the dominant mode of learning is inductive for the most part. Recall that AI is not just deep learning. There is another school called symbolic AI that is more rules-based but suffers from the critical limitations of writing route rules or an incredibly inefficient series of if-then statements on some level. Yet aside from seeing the world as a collection of pixels or text or a series of numerical representations in a computer, we humans have ontological tools for representing the world through symbols. That can be topic for another AI talk already, and it will be interesting to talk about it again when there are new developments made in the space of writing rules, enabling new ways of seeing. An object-oriented way of seeing the world with machines that is non-Anthropocene allows us to take a step back, and from the comfort of a distance, ask fundamental questions about the nature of reality, such as, what is the relationship between the written word and an image? And to translate this into everyday work, how would this implicate the way museum labels are written? Aside from raising old questions anew, working with machines enables new solutions also. Now let's see how you can point and click your way to a neural search engine on your collections, and all that you need to get started are your images and a CSV containing some basic information such as titles and artist names to search over. While traditional keyword-based approaches require extensive annotations and do not scale well to user typos or other languages, these are all problems that neural search can solve for us. Searching of machine-made neural networks can then help us to go beyond existing metadata. And not only that, we can go beyond text to incorporate images in our queries as well, allowing us to adapt to new user habits and behaviors. For the purpose of this demonstration built using Gina, a multi-modal AI platform, I'm using part of the collections from National Gallery Singapore. Before we can search over any data, we want to first model such documents, in our case, image and text. And we make use of Gina's data class feature in order to do that. Data class is a high-level API for representing multi-modal documents in a nested document structure. Then, we instantiate the data classes with our actual data and cast them to documents. Then we upload. Note that you need to be logged into the Gina cloud in order to upload your documents. Once your upload has been completed, you can then log into the Gina cloud to view your uploaded data and build your search app in the web interface. We can now go into the Gina cloud to build our search app. And you will see that this is what we have just uploaded. Now, in order to build the search app, we go over to search and click on new app. Select the data source, which is what we have just uploaded into the JCloud Docker array, and then the artwork data that was uploaded. Then continue. And then essentially all you have to do is select how we want to index over the text. So we'll be making use of title, for example, and of course the image. You can also allow for filters as well. And then just click on deploy. Then we wait for it to finish building. Once it is done, we can now search with text. Notice how it understands that a bunny is related to a rabbit, so it extends what we already have in the title. Next, how about something like angry people marching? And here's what we found. Maybe this artwork will be relevant in an article about the dangers of AI. Aside from text, we can also search with an image. The score breakdown shows you how the machine has mapped our query against image and text encodings. We can refine this with red in the text, so this becomes a multi-model search. Multi-model neural search thereby enables us to go beyond existing metadata, work with different media types, as well as address issues around typos and multilingual queries by doing a similarity match. What if we combine different museum collections together? Can you start to imagine how machines can help us to make sense of seemingly disparate data sets, linear connections, as well as to search and retrieve for exhibition planning? Algorithms are a series of steps that the computer follows, so depending on how we write these recipes, the machine ranks, then re-ranks results. What fascinates me about the digital is that here, physical laws need not apply. We are free to make choices about how to categorize information, about how to search through them. We're also free to reimagine how an algorithm primed to search and surface the less visible might look like. In this sense, digitalization is perhaps a matter of rights. Yet somehow today, art and technology feels a lot further than they were during the Renaissance. If we approach AI thoughtfully, however, it can be especially powerful for a sector short on manpower and budgets, for the power it confers in automation and augmentation of human efforts. All these capabilities rest upon the critical assumptions that digital representations exist to be built upon. The question of justice then comes into play. When thinking about inclusiveness of digitalization efforts to ensure dual representation at the base data level, which then lays the foundation for apps and services to be built on top of this to unlock opportunities and access. What we can do is report on model cuts and data cuts for transparency and reproducibility, in the spirit of doing good science. Now that we have seen how easy it is to see and search with machines, in fact, if you are curious, feel free to check out my Git repository for the code so that you can deploy your own POC on your productions. After the POC, how then do we take this to production? There is usually a very complex ecosystem of apps and services to be built for a fully functioning search service serving a live audience. And the good news is that much of that complexity has really been abstracted away or taken care of for you in the demonstration that I just showed. So my quick take on this is then that some form of shared managed services on top of open source technologies could be the possible way forward. There is a lot to be gained by powering OpenGlam with open source technologies and contributing to a common pool together. Symbiosis here is possible because of shared values around openness, and both pieces play an essential role in society as hedges against monopoly power, allowing for greater participation in software and cultural assets. Everything sounds rosy and peachy so far. You can take my code and demo to apply neural search to your collections and pay for API access for a solution that will scale and return results for you immediately. Yet, I do not want to discount the challenges of taking AI from POC to production, because it's not as if the art world has never embarked on such projects before. In fact, there has been a consistent POC to production gap not only in the art world but in many other industries as well. And to quote a paper published in Museum Management and Curatorship looking at the application of computer vision to collections in 5 institutions in particular, quote, "Results have not been implemented into a production environment due to required staff time and the need for ongoing expertise around AI to maintain the projects," end quote. This is in line with my personal observations that I think 3 C's come to the fore for taking AI into production, namely cost, capability, and counterfactual. The first 2 are rather self-explanatory, and the third point, counterfactual, is really just trying to capture this idea of, so what if we do not adopt AI? While private companies live and die by the bottom line, so there is a real urgency to adopt technologies for greater efficiency, cultural institutions face a very different set of competitive pressures. Perhaps even the perception of what to compete on is highly varied, right? To me, the silver lining here is that as a global community, we can take a collaborative approach to address common challenges around cost and capability together, to coordinate and address these issues collectively, driven by a mutual desire to do good in the most effective and most efficient way possible. These 3 C's are the practical cultural challenges that cultural institutions face in putting AI into production, even after a successful POC rolled out. Then there's the business considerations around buy or build. Bear in mind that such a buying or building decision is constrained by confounding influences in the 3 C's that I just mentioned. Starting with the best possible end state in mind, though, I would argue in favor of shared managed services or group buying option to source and hire digital talents from all around the world to build what's necessary on top of open source technologies. Organizations like Transcribers, an AI-powered platform for text recognition, image analysis, and structure recognition of historical documents, already exist to service 135 members from 30 countries according to the website. Why not extend this logic and tap into a global pool of remote talents? Why not apply this to other use cases or clusters? I think there's a lot of room for experimentation in terms of how we approach work and putting AI into production, to branch off into experimental features and developments that can be merged back later. Once we consider the triangle of sovereignty, cost-effectiveness, and performance for putting AI products into production, it strengthens the case for open source software. For organizations that don't have a huge IT budget to begin with, I think it's important for us to find the cost-effectiveness and performance side of this triangle when it comes to deploying any tech solution in production. That means if you cannot afford to build and maintain a model in-house, and the con of losing that sovereignty is then that obviously if whatever API or service I'm calling goes under, everything breaks apart, right? One way to mitigate this is to use open source products coupled with managed services. So part of the Gina ecosystem falls into this bucket. And as far as cost effectiveness is concerned, by extracting away the different layers of complexity involved in ML ops for such a system in production, it's safe to say that using such a managed service will be more cost-effective than maintaining a huge team of in-house engineers. Most public organizations do not have such engineering teams in the first place, so realistically, some form of managed service will better suit needs in these scenarios anyway. Finally, in this particular use case, to me, whatever outperforms the existing keyword-based search system checks off the performance criteria. Depending on the product of interest, the evaluation metric to be used can be refined accordingly as well. Ultimately, though, what emerges is then that some form of managed service building on top of open source technologies could be the possible path forward to accelerate development. Embracing open source innovations this way gives us the flexibility and starting point to harness a global community to build together as we figure out how to build internal capabilities in parallel. The Unreal game engine is open source too, to MySQL and lots of AI libraries. I cannot emphasize the open and global aspect enough because such openness allows us to stack and integrate other software or libraries with this easily. But global reach also dramatically increases the pool of people that we can potentially work with. It becomes another possible proactive mode for citizen developers to engage with collections.
This is really possible. An end-to-end AI-powered collection search system built by citizen developers from all around the world, managed by a team of museum professionals that not only automatically crops artworks but updates them to be immediately searchable and accessible right away. By integrating with other open systems, such as collections management software, we can minimize workflow disruptions while stacking in new features, such as impact tracking, or connecting with other data sources or institutions to map cultural influences. All that we need to get going are to initiate conversations, gather resources, and start building. In other words, I'm suggesting in software terms a branch to the way that we work and approach AI that can be containerized and tested in other branches, then merge back into the main branch of things once proven. Thank you for this opportunity and for your time. And this presentation would not have been possible without the support of my various teammates, the collections and IT teams at National Gallery Singapore, and shout out to Gina for open sourcing innovations. If you would like to collaborate together or build learning communities in any way, I would love to have a chat. Aside to that, happy to take any questions they might have as well. Let's get cracking!